Larry Smart is here from the horticulture department in Geneva, and he's doing willow work here, and he'll talk about that.
Thanks, Terry. Thanks everyone for coming. It's great to be here. As Terry mentioned, I'm a professor in horticulture based at the Geneva campus of Cornell. Also have a joint appointment in plant breeding and genetics. I've been working on willow for 20 years as a bioenergy crop, and we've been very fortunate to work with Terry and his staff here who are hosting this genetics trial for us. Willow is a very sustainable crop for the production of wood chips that can be used to generate electricity, can be used for biofuels, as Senator Young mentioned, or it can be used for heating. And on our Geneva campus, we have a biomass boiler that heats 2 of our buildings entirely with willow chips. This is a genetics trial with 130 different accessions, wild accessions of willow that we've collected from across the Northeast. Each one unique, and we have sequenced the DNA of each one, and the goal is to measure the performance of these different willows. So we measure stem diameter, stem height, pest incidence. We're very interested in rust incidence and mapping diseases for rust, so we can correlate the variation in those traits in this genetics trial with DNA markers from our DNA sequencing, and then develop molecular markers to speed our breeding program. So this trial is replicated in Geneva and in Morgantown, West Virginia, and it's really been essential for helping us advance the molecular breeding program for willow. This trial was planted in 2012. We've harvested it twice. We harvested it, cut it back this past winter. So this is current season growth. It's about 10 feet, maybe some of them are 12 feet. Right now, it should get up to 14 or 15 feet by the end of the season. We harvest it every 2 years. Thanks, Terry.
Thanks. Thank you.